Hello class, this is a video tutorial on the sine rule. So in a non-right angled triangle and given a pair of angles and their opposite sides, we can apply the sine rule. Sine rule is as follows: A on sine A equals B on sine B. Now it's very important to understand the angles and their opposite sides. So in this case, angle A is here, and its opposite side is labeled lowercase a, and if this is angle B, its opposite side is lowercase b. So utilizing this formula or this rule, we can use this to calculate missing sides and missing angles. So let's get two examples here. Here we go. So for this, we want to make x the subject, so let's have that as the top leftmost. So it's going to be x over the opposite side, the opposite angle, so x over sine 67 is equal to 18.7, the side, over sine of its opposite angle, 83. So sine 83. Like we do with regular trigonometry, we're going to eliminate this denominator by multiplying by sine 67 on both sides. This will eliminate this one. Those two will cancel, leaving us with x is equal to 18.7 times sine 67, so 18.7 sine 67 all over sine 83. Plugging all of this into our calculator, we will get 18.7 sine 67 all over sine 83. This will give us 17.34 ... and we'll just round this off to two decimal places, so 17.34, and it's in centimeters, so 17.34 centimeters. We'll do another example here. You can go ahead, pause the video and give it a go yourself, but here we go. I'm going to make y the subject, so it's going to be y over its opposite angle of 22, so sine 22 is equal to the side 23.2 over sine 108. This will give us, we're going to multiply by this denominator, so times sine 22 on both sides. These two will cancel, leaving us with y is equal to 23.2 sine 22 over sine 108. So using our calculator, 23.2 sine 22 all over sine 108. This gives us y is equal to 9.138, and we'll just round this off to two decimal places as 9.12. in meters, so the answer stays as meters. Now, this very same rule can be modified to be used for angle calculation. So normally we have the side on top of the angle. We can flip this to make it sine A over the side equals sine B over the side. So it's literally the same formula, just with the ratio switched back and forth. So let's demonstrate how this would be used. So in this case, we want to solve for P. So we're going to do this as sine of angle P over its opposite side. So from P, its opposite side is 12.5. So sine P over 12.5 is equal to sine 68 over its opposite side of 17.1. Multiplying both sides by 12.5, this leaves us with sine P is equal to 12.5 sine 68 over 17.1. And solving for P, we take the inverse sine of both sides. So P in degrees is equal to sine inverse of everything here. And using a calculator to solve that, we will get sine inverse of 12.5 sine 68 over 17.1. So to the nearest whole degree, this will give us 42.6693, which approximates to 43 degrees, the nearest whole degree. Let's do this one more time. Once again, we're going to solve for angle Q. So let's make this as sine Q over its opposite angle side, 12.2, is equal to sine 118. So sine 118 over 32.3. Multiplying both sides by 12.2, sine Q is 12.2 sine 118 all over 32.3. Solving for Q, we take the inverse of both sides, so Q is equal to inverse sine of, just gonna copy paste this, of everything there, and this will solve it for us. Here we go. Sine inverse 12.2 sine 118 all over 32.3. This is exactly 19.4811, which approximates to 19 degrees to the nearest whole degree. So I hope that gave you an insight into using the sine rule to calculate missing sides and the sine rule to calculate missing angles. Hope to see you in the next video. Best of luck.